So on the posterior side, you're going to find the posterior root ganglion. The part that we see, this yellow rope, okay, that is your spinal nerve, containing both fibers, afferent and efferent. Now you're probably wondering, why is she spending so much time on this? How could this be clinically significant? If they are damaged. And what would that affect?
Information you get from somewhere it's supposed to go.
Information, first of all, information that may need to go in would be damaged. The effect that needs to come out would be affected. Now, let me make it a tad bit more interesting. What happens with the spinal nerve? Do you guys remember how when we looked at the posterior and the anterior side, I also mentioned the lateral side to get you to note those lateral tracts? Okay? Where did information from the lateral side go? Organ. The information, the innervation, okay? The innervation for your internal organ travels by way of your spinal nerve. Now think about that for a second. Innervation for your organ travels by way of a spinal nerve. Now, what have I done to the clinical significance? Have you ever seen that picture in the doctor's office with the nerve being shown leaving the spinal cord and everything that they innervate? No? Yeah? Yes, no, maybe? Okay, let me see if I can find it. That's fine. Oh, man. Now, have I changed your view now on clinical significance? The red is representing the nerves that exit those vertebrae and organs that they supply. Now think about nerve damage. Exactly. Spinal nerve damage. All this stuff that's coming out here from these bones in our back that's feeding all of this stuff to the outside of our body will also have the route that can begin to feed the internal organs. For example, people who have low back injuries tend to have problems with their bowels. Does that make sense? So, I know you're thinking, okay, well, I was wondering why she was spending so much time. That's why. Because it is so clinically significant. So, it has those 3 layers, just like everything else that we've talked about. We're going to have an endoneurium, we're going to have a perineurium, and we're going to have an epineurium. One of the other things that I want you to note about the anatomy, these nerves are very well vascularized. All right? Because the one thing that's going to happen, you don't want anything to affect transmission of information. So they're very well nourished, all right, very well vascularized because, that vascularization allows for keeping them in proper shape. So we're going to find that in the peripheral nervous system, the nerves are covered in myelin. What's the difference? In the central nervous system, brain and spinal cord, we mentioned that even though we've got this gray and white matter, where people tend to associate gray matter with it not being myelinated. It's not as myelinated. Okay? Now, that part of my nervous system, the brain and the spinal cord, they're encased in bone. They are very well protected. Now I have nerves that have begun to exit. They exit through the vertebra. All those foramen, you guys remember that term? Okay, what does that mean? The hole. The way those vertebrae articulate, do you guys remember there were lateral holes? There were ones on both the ventral and the dorsal. The nerves get to exit out of those foramen. They have now left safety. They're not encased in bone. They've got to be protected. The Schwann cell, think about that long string, because really, that's sort of what that nerve's going to look like. Okay? I got this long string, and all the way along it, Schwann cell, Schwann cell, Schwann cell, Schwann cell, Schwann cell. I can't say that too many more times. Okay? How did that Schwann cell create myelin? This should have been from part 1. No? All right. Okay. Let's say egg and sperm meet, fertilization occurs, baby begins to develop. As they begin to develop, nerves are going to begin to form, and we begin to see, y'all think of my finger as one of the nerves, okay? We begin to see the laying down of a Schwann cell on those peripheral nerves. And then it's going to secrete the fatty tissue and start making a wrapping. And it's going to do it the entire length of that nerve. Okay? Now, baby is born. As the baby continues to grow, it's going to keep laying down more fatty substance until roughly about the age 3 to 5, when it gets complete. And around that part of the nerve, I've got a wrapping. I have this protection. It's a fatty substance that's been laid down by that Schwann cell, and it's done it here, and here, and here, and here, and here, and here, all the way the length of that nerve. Does that make sense? In the makeup of that nerve, the 3 connective tissue layers. Does any of this look familiar from anything that you might have studied in part 1? We've got the 3 layers, but does it look familiar to anything else that you might have learned in part 1? How about the skeletal muscle? Wasn't the skeletal muscle made up of these long fibers that were formed into fascicles that began to get wrapped, and you formed a muscle as a whole? Have the same thing right here. We've got the fibers. Now, let me think here for a second. What is going to be making up the fiber of this spinal nerve? All right, let's go back to our concept of a nerve. Nerve cell body, dendrite, axon, terminal end. Where are my nerve cell bodies located? In the spinal cord, and the dorsal root, the dorsal root ganglion, for example, is composed of nerve cell bodies. Everybody understanding? What did I just say? Where's Marlisha? Okay, if we're using the dorsal root ganglion as an example, it's going to be found in the dorsal root ganglion. So where is my axon now found? What is that making up? The what? The nerve. The spinal nerve. Does that make sense? This, what?